Yeah, hello, welcome. I'm really glad that you decided to join our session today. I hope you're enjoying staying at Amsterdam and you're enjoying KubeCon this year. My name is Grzegorz Panek and I'm a research engineer for the Orange. And today with Piotr Matysiak, we are going to share with you the output of our project called Edge Relocation. So basically, we are going to talk today about the seamless migration of the cloud-native workloads across multiple edge clusters, multiple edge servers. So first of all, I will give you some motivation from our side, how we see the edge and why we are taking care about the edge. And later on, I will give the floor to the Piotr that will give you a deeper view on the technical stuffs, how we are managing multiple clusters and how we implemented edge allocation procedure. And finally, I will give you some notes on the future research direction of our project. So currently, Orange is deploying its own 5G network, 5G connectivity, because we believe that the edge computing is not enough to achieve the low latency communication. In order to take profit from the low latency communication for the edge services, we need as well really rapid radio access network to the edge services. And we think like an integration of the 5G and edge infrastructure will give you and will give us a whole opportunity to take profit from the low latency communication for the edge computing. Nowadays, more and more partners, industrial partners are asking us, are you already able to deploy our own services on your edge infrastructure? And during these exercises with industrial partners, we noticed that a lot of or majority of the use cases that the partners are developing are characterized not only by the low latency communication, but as well about the end user mobility. So we notice a functional gap, how to take care about the edge application and the end user mobility, how to take care about the service continuity for the users that are in the mobility state. So we identified some gap procedure in the ecosystem that is a migrating of the edge application from one edge cluster to the another edge cluster because of the following the end user. Maybe I will give you the more visual view on our problem that we are dealing with. So let's imagine that we have an autonomous vehicle steering system that is deployed at the edge cluster. However, as we know, the users, the cars are moving and are approaching different geographical location. So it may turns out that once the user will change its position, it should be handed off to the another G-Node B, to the another access network station. However, the edge cluster that is closest to the targeted edge, targeted radio access network, is not ready to handle the end user request because the edge application is not there yet. So we implemented an edge relocation procedure to move this application from one cluster to the another seamlessly in order to guarantee the service continuity for the end user. But you may ask me, okay, why not just to replicate the edge applications everywhere? That will solve the problem. But we did exercises with our operational team, and it turns out that the deployment of the edge infrastructure is really costly. And we need somehow to optimize the utilization of the resources and the whole topology. That's why we decided to implement some procedure that based on the follow me approach, okay? So if the user is requesting to access some application, we are just on demand creating this application there. But it's not only the one reason why we need to take care about the relocation, edge relocation. We should guarantee as well, for instance, the load balancing for our resources in order to increase the capacity of the system. We can imagine that one of our edge servers would be off due to, I don't know, maintenance reasons, power outage or something like that, or we are just wanted to move our application or move our infrastructure to the other cloud provider. So all the use cases that I'm mentioning requires moving the application from one cluster to the another with no service disruption for the end user. So just before going floor to the Piotr, I will give you a view on our real objectives of the project and real contributions to solve this project. So in fact, we implemented two procedures. The first one we called Edge Relocation, and this is about the seamless migration of the containerized application between the clusters. And the second that we called lifecycle management of the Edge application, but in fact this is the lifecycle management of Edge application and the end user management, because this procedure is observing all the time, thanks to the 5G network, it's observing all the time the user positioning, the radio conditions, it's observing as well the Edge infrastructure utilization, and based on this observability stuffs, we are taking a decision whether to migrate our application or to stay at the source Edge cluster. So to implement that, we implemented some smaller proof of concepts that we can mention. For instance, observability controller that is all the time monitoring the resource utilization at Kubernetes clusters. We implemented as well topology controller that is taking care about where the Edge cluster currently is located. Maybe not just is taking care about the Edge infrastructure. Is aware about whether the cluster is overloaded or not. And finally, we implemented a placement controller, which implements some mathematical modeling, some mathematical optimization on analysis whether to migrate our application or not. I will give you more detail about all the controllers in the next slides. So now, Piotr, the floor is yours.
Thank you, Greg, and it's a pleasure to be here. I would like to talk about why we are at this event and how we place at this event. So we talk about the edge. You can imagine that we have different types, different layers of edge, far edge, mid edge, close edge, of, if you will, cloud, fog, or just edge, or you can have different type of layers, you call it as you want. And on top of that, we would like to have some control, management plane, some kind of orchestrator. So we are at the edge, and to place us at the Kubernetes event, we assume that each edge cluster is a Kubernetes cluster. It's separate cluster with its own management, with its separate control plane, and of course separate worker nodes, and if you will, also the cluster may be from different providers, different kind of clusters, bare metal clusters, managed clusters, etc. And for the orchestrator, I don't want to go deep dive into why we took the MCO, which stands for Edge Multi-Cluster Orchestrator, but what we like about MCO is that it's intent-based. There are a lot of type of intents. The most important is for us the placement intent. So it's crucial to remember that we have placement intents in the MCO. And also, it's composed of many different controllers. Again, the placement controllers are the most important for us. And MCO introduced some mechanism to take a lot of clusters from different provider and different types of clusters under an umbrella called logical cloud. And then we can deploy on those clusters applications using MCO APIs. We can deploy application on single cluster, on the set of cluster, it depends. What we do not like about MCO is the lack of the functionalities that we would like to have for our use case. So we extended the MCO with the relocation workflow, as being said. And in fact, the relocation workflow itself, it can be defined in the MCO via endpoints as an intent. So in the intent, we can specify what application should be relocated where, to which cluster. And if we deploy, if we invoke such relocation workflow, the following procedure will be proceed. So we will collect the information about the placement intent. Based on the relocation intent, we will update it. Of course, the changes will be applied, and the reconciliation will take turn. But we will not delete the old instance from the previous clusters. Before that, we need to make sure that the new instance is ready, so we check for the readiness, and then we steer the traffic from the user, which can be external from the cluster, so the service mesh is not always the solution. And only when we steer the traffic, we can, under a condition that this application is not shared application, there are no other user who is using this application, we can again update the intent about placement and remove this application. I don't want to show any demo. We are constrained on the time. The system makes bigger and bigger, so I will show the abstracted way on the slides. So imagine that we say to the MCO APIs, we want to deploy the application X, for example, on Cloud 1, and it's deployed. And then we can send the second request to the MCO APIs with the relocation intent that we would like to relocate the application X to the, for example, FOC2. And following the procedure I showed you in the previous slides, the application, of course, will be relocated from Cloud 1 as shown to the FOC2 with almost, it will be almost seamless migration. The traffic steering thing is work in progress. We have a simple solution, but there is a lot to do more. But as you can see here, we have some manual invoke of the procedure, which is not the case, for example, in the scenario where we have vehicles which are moving, because there will be no admin who will define and trigger such relocation. So we deep dive and we develop another two components, at least two components. The another workflow, which is LCM workflow, and the placement controller for our own placement controller, additional for the MCO. So for the LCM workflow, it's almost the same as the relocation. I mean, it's also intent-based, so we can define the intent for the LCM workflow, where we can specify the application requirements, for example, for the latency, for example, for the resource, how many resources the application needs, probably also the type of algorithm to take into account when we will try to select the best cluster. And this is as follows. When we start the LCM workflow, at the first, we subscribe for the notifications. In our use case, the telco use case, we had only one source from the IMF, which is a network function of the 5G control plane. And we received the notification about the user movement from that point. We could subscribe for many type of notification from many different source of information. It depends on our use cases. This is for a proof of concept. So when we subscribe for the notification, we enter the loop, which is running for the entire life cycle of the application. So we listen for the notification for the relocation. If it occurs, we call the placement controller and ask, make the decision where the application should be moved, where is the optimal place. And we wait for such a response. If this response is received, we can make use of the relocation workflow described earlier and generate such relocation workflow and invoke it. So this is about the LCM. The placement controller, it requires some source of knowledge to make the decision. So the first source of knowledge is LCM workflow, where we define requirements, and the second and third are the topology controller and the observability controller. We define proof of concept versions of those. And going deep dive, placement controller receives also the intent. So as a request, it receives the intent to select the best clusters, and in the intent we specify the information which were provided in the LCM workflow. So application requirements, the type of algorithm which need to be selected to provide the placement, and of course we also utilize the topology controller information, for example the location or the latency information, but it's up to some kind of topology, some kind of edge provider which can provide such topology controller to define what information we can get. It's the same for the observability controller. Here we observe the resources on the Kubernetes clusters, and based on that, we have here at least 3 sources of truth, and based on that, we can select one of our algorithms which we define, for example, optimal or heuristic, not going deep to the implementation details. And the placement controller will send to us, will respond with the best placement for our application. So to show you an example, we deploy the application manually as we did, and also we define the LCM workflow. So LCM workflow at the time of deployment is started, and it will work until the application is killed. So it will listen for the notifications. If it receives the notification, of course, it will automatically make the decision and trigger the relocation. In this case, from Cloud 1 to Cloud 2. It will continue, and if we receive another relocation request, it will again make the decision and make the relocation. We can do it as many times as we want. I think you got the idea. And the LCM workflow can be started for many applications, so we can deploy any number of applications as we want, and they will be separately. Decision will be separately made, of course, on the same infrastructure. So the different application will make the decision. The decision for one application will somehow impact on the decision on the second for the second application. But this is an idea. So for us, this is not yet targeted for the product. So this is open source. And this is as a proof of concept shown. So it's still work in progress. As an example of further work, we also consider the machine learning reinforcement learning agent to interact with from the placement controller side. And based on that, we believe that we can further optimize the decision which cluster is the best. But I think I showed you the general view and our process, how we are here, and I think right now I can give a hand for the Greg to continue. Thank you.
I don't know if Piotr, you mentioned that the edge relocation procedure that we implemented is already open source. So if you are dealing with the similar problems of the migration of the application across the clusters, you can just take it from the open source. The link was included in the presentation. This is a part of the EMCO project currently, Edge Multi-Cluster Orchestrator project. But in order to make some fun with the procedure, we decided to integrate open source 5G network with the partially open source MEC system and partially done by us in our project. So as you can see, we have a 5G core that is all the time informing us about the user position, about the radio conditions for the user. We can still monitor what's the status of our end user, whether it's handoff or whether it's doing some movement or not. Because as you can see, in order to user will access the Edge application, it needs to access through the 5G access network. So we implemented as well the observability controller that is constantly observing the resource consumption at the different clusters, Edge clusters. And finally, we implemented placement controller. As Piotr mentioned, this is the place where we implemented heuristic and reinforcement learning algorithms in order to decide whether to relocate or not based on the intents received from the 5G and Edge infrastructure. Okay, topology mapping, how we did that. So for the 5G control plane, we take profit from the free 5GC project. It implements as well a data plane. For the access network and the simulator of the end user, we took profit from the UE Run Zim project. Our Edge clusters, Edge hosts were implemented as a single separated Kubernetes clusters. The service orchestrator that we have in this architecture, we took profit from the MCO project, which I mentioned before. And for the observability controller, we implemented like a Prometheus plus Grafana Mimir solution. The placement controller is our own child, let's say. The same for the network and MEC topology. So this is the last slide. I'm not going too deep in this project because this is more mathematical modeling. But as Piotr and I mentioned before, we are receiving multiple notifications from the 5G control plane, from the Edge infrastructure. And so first of all, we implemented the heuristic-based approach on whether to migrate our application or not, based on some CPU memory measurements, based on some latency observing. And currently, our ongoing work is implementing reinforcement learning approach in order to the agent, let the agent learn our Edge topology, let him know how to react in our Edge mobility case. So thank you a lot. If you have any question, please.
Anybody got a, okay.
Hi, Cześć. Thank you for your presentation. I have a question about how, maybe I missed that, but maybe you did not describe it. How do you describe the application and the services in the first place? I mean, what kind of manifest format are you using? Are you using Terraform, Tosca, things like this?
Could you repeat? It's hard to hear on the stage here.
Sorry about that. So my question was, when you describe the application, what kind of manifest format, what kind of domain-specific language are you using, or are you using any of those sort of domain-specific language? Are you using Terraform, Tosca, things like this?
Yeah, in fact, right now we do not care about the infrastructure creation, so we assume that the infrastructure is here. We just register the clusters. And for the other manifests, I believe everything is in the YAML format, which then is, parsed in the programming languages. We also use Helm packages to describe the application. So the Helm package is the input for the MCO project.